is in the hands of your enemy. So what he or she will do? Blackmailing, right? Or ask for some money, or some kind of these malicious persons will do the things. Correct or not? But how to address these issues? Biometrics. The next solution is biometrics. But how biometrics will help us from these things? Right? So no need of ID card, no need of remembering passwords and all these things. You can use simply your fingerprint or face or iris or some form of biometric characteristics to prove yourself. Because you know that main advantage with biometrics is that they are with you. They are with you. Correct or not? Your finger is with you only. Your face is with you only. Right? But passwords, your absence also, malicious persons, they are using your passwords to enter into your world. Correct or not? Passwords are like ID cards. So they are maliciously, they are taking your credentials and they are accessing your world. That is a limitation. But with biometrics, the biometric characteristics like face or finger, your finger is with you, your face is with you, your eyes is with you. Right? So no one can forge. Is it correct? Correct or not? So that is the advantage with the biometrics. So nowadays, in every application, even for ration, pension, banks, correct or not? Phone, your laptop, your home also. Your home also, it will be unlocked when you use your fingerprint or face. Right? Everything. But again, there are issues with the biometrics. What issues? What issues? I can create your, let us assume we are using face biometric. I will take your photo, instead of your face, I will present your photo to the scanner, your photo to the sensor. What will happen? Your photo is also similar to your face only. Then what the system will do? It will accept the malicious user. So what I will do? I will take your face and present your photo means with my body. What will happen? I am a malicious user. I want to take your gold like from your aura. I want to enter your home. Right? So possible. Correct or not? Like that, fingerprints. You know, lot of spoofed fingerprints. Spoofed fingerprints. Forged fingerprints. Fake fingerprints. Possible. Even with the wax and fake. Fake, forgery. All methods are. Okay. So we are using biometrics to fight against. We are using biometrics to fight against malicious attacks. But biometrics themselves are prone to attacks. So whatever I told, like spoofing is possible. Your photo I can use to present to the sensor, to the camera, so that the malicious person can enter into your, right? So these are the possible. Then how to address this issue? How to address this issue, right? So we need to have an intelligent system. What intelligent system? That presented photo or presented face is fake or real. Again this is a intelligent system, right? We need to develop a model such that it should distinguish the real fingerprint from the fake fingerprint. But how it will do? Based on training. So training means what we need to have? AI. ML models are again required. Okay. Right? So that is one issue. That is one problem. So nowadays, deep fake with the tools itself, AI generated tools. So in the last session, we discussed like augmentation. What is augmentation? Creating actually that part called data set. I have only 431 images. But to train a DL model, 431 images are not sufficient. So we need to have larger data set. We need to have more data. So what we did, flipping, rotating, scaling, those things we discussed, right? Nowadays, people are using AI to generate fake. AI to generate fake, deep fake. You know, lot of issues came recently. Modi and this, Ukraine war, people use deep fake to generate that is Prime Minister's voice and something. Correct or not? So nowadays, deep fake audios, videos are common. That is again fake. How they are generating using AI? Using AI, right? So those models actually called GANs. Generator Adversarial Networks. Okay? So what GAN will do? It will just generate the fake. Why? Mobile. Are you using mobile now? See, if you don't want to listen, just go out. Because you are students, you should be like student only. Right? So people are using AI to generate the fake. So, training a model, one session I told, augmentation we are doing. So that augmentation, what it is, generating some duplicates of original image. My image, right? Rotated form, scale form, right? So, this deep fake, this AI also is used to generate the fake. But that fake purpose is, there it is for training, more training. But we need to have the models to distinguish whether that is a fake or real. So that is one area of work where you can work on your project. Okay? Like forgery detection, forgery or fake detection, right? Then the next problem with biometrics is that, I'll ask you one question. If you let us assume you came to know that your password is compromised. You came to know that your password is compromised. How you know your password is compromised? Generally, how you know? If some amount is deducted without your knowledge. Without your knowledge, some amount is deducted. Or in your send box, like Gmail. Without your knowledge, some message was sent, some mail was sent. Correct or not? So, hey, you came to know that your password is hacked or it was compromised. Then what you will do? What is the next option for you? Block. Otherwise, instead of your account, you are maintaining, let's say, my Gmail account I am maintaining from 97. Not 97, exactly, close to 97 it is Yahoo. Yahoo.com. Okay, so see, many of my friends know my personal mail. But now I cannot log my personal Gmail. But what is the next option? Change password. Very important. What is that next option? Change password. Forgot password. We will click on forgot password so that what it will ask? Create a new password. Means cancel the old one, cancel the old password, compromised password, and you can have a new password. That is one solution. And let's say your ID card is lost. Next option. What next option? You'll go to admin office and pay a fine of 100 rupees or 200 rupees or even 1000 rupees, and you can claim for. You write a letter, sir, I lost my ID card, so please issue a new ID card. So what will you do? They will give you a new ID card. But your face, now coming to biometrics. Your face is compromised. It means your face, like your photo or your this thing is in the hands of some third party, malicious party. Once your biometric account is compromised, because same face used for all applications, correct? All applications, banking, your Gmail, everything, right? Your social media, everything. So all applications will be compromised. But what is the solution again? So like password, what will happen? If the password is compromised, you will click on forgot password and you will get a new one. Likewise, your ID card is lost, you can get a new ID card. But your face is lost, get a new face. Will you get a new face? Your finger is compromised. You have how many fingerprints? That is compromised. Whatever 11 fingerprint. Permanent loss. If Gmail, your password is lost, that is a temporary loss. Right? temporary, right? You can get a new password, but your biometric is last. Correct or not? Then how to address this issue? How to address this issue, right? See, if you see the Aadhaar system, so what Aadhaar will do in Aadhaar registration, how you are registered with Aadhaar? Eyes, face. Okay, remember exactly because it was given in 2010 or 11 or 12, almost 10 years back, right? Biometric Aadhaar system came. So all these Aadhaar people, they collected our samples. They collected our samples and where they will store them? Where they will store? In a database. In a database server, right? Now the malicious user attacked that server. Attacked that server. All of the data is increased. All of the data is in increase, correct? So he can use them any purpose, right? He can enter your world, right? He can do the damage. He can do the damage. Then how to address that? So why? You can ask one question, why to store them in the raw form, image form, raw images? We can extract some features. Like they have some features like no length, high speed, then lips width, height, and some landmarks, around 50 to 60 landmarks will be there on our face. Okay, so those facial features we can store in the database. Facial features can store. Likewise, for fingerprint, you know, every time you observe, there are set of ridges. Ridges and valleys. So there is some feature set. I tell you if I explain that, you will not get the things. Okay? But some feature set will be there. So you can store the features instead of raw image in the database. Are you getting or not? Instead of storing, so what I said, if we store the our biometric, the spaces, fingerprints into the database, we will get this. So instead of that, what is the next solution? We can store the features, face features, like color, or these means different. Every human will have unique face, right? Almost. Even twins also, little different face will be there. Some differences will be there, right? But again, that is also a risk, because why? With features also we can get the face, correct? How we can get the face? See, with the features also we can draw the image. In lot of movies means చాలా సినిమాలు ఉంటాం కదా, వాడు చెప్తాడు ఆడు బ్లాక్ గా ఉంటాడు, కులంలో పెద్ద ముక్కు అన్ని చెప్తాడు కదా, అని చెప్తే ఏం చేస్తాడు, స్కెచ్ చేస్తాడు. yes, is it true or not? With feature set, because suppose some incident happened, so that witness people, they can describe the features. So based on that, the artist will draw the. So this was also happened. From the feature set, the reverse engineering is possible. From the feature set, you are disturbing some word, but because it is not possible for me in my class also, I will expect silence. Otherwise, I will not teach to my students. Okay, if you don't want to listen, please go outside. But don't make disturbance. So I come here because of that purpose only. Right. So from the feature set also, there is a possibility of getting the original image. So features, that is also, again the problem again came, right? So we cannot store directly the raw image, and we cannot store the image features of the images, face or fingerprint, right? So again, what is the next solution? So we need to provide security to the features. So that feature set is called template, biometric template. So from biometric image, next biometric features, right? The features are called template. Okay, so we need to provide security to those templates, biometric features. So that is called biometric template security. Right? You know cryptography? Encryption, decryption. You know little bit, I think. Encryption, decryption, right? So there are many solutions for biometric template security. We'll discuss one by one. See, so these are the characteristics that should be satisfied by a biometric template protection method. Irreversibility. What is irreversibility? We cannot get back the image. We cannot get back the image. So this function, whatever we are using, should be a one-way function. One way. The reverse should not be possible. The reverse should not be possible. Generally, people will use hashing functions to do that. Hashing functions in security. Okay, hashing techniques. People will use that. Right? Then revocability. What is revocability? Cancel the old one, create a new one. Cancel the old template, create a new template. Like our password, like our ID card. If compromised, see, even though we followed some techniques to protect that template also, always the attacker comes with new ideas to break that. See, there is as technology is growing, the counter, that attackers also comes with their ideas to break the system. Always this is a cat and mouse. What is that called? Mouse and cat or ante kada fight elka pilli madhyane kada. Tom and Jerry, cat and mouse, whatever it may be. Because mouse always try to escape from cat. Mouse always try to escape from the cat. But what cat will do? Always try to catch that. Right? So same, attackers always try to break our system and we always try to secure our system. Right? So there is a fight between users and the attackers always. Right? Now let us assume your template is compromised. So we need to create new. We need to cancel the old one like your password. We need to cancel the old password and we are generating a new password, right? So likewise, we have to cancel our old template and generate a new template. My brother's son actually, so he's having some issue. Always he'll having some. Right. Okay, so that is what is called revocability. Now, unlinkability. What is unlinkability? See, unlinkability. Suppose I am using a technique such that I need to protect your template. Means I am generating a secure template for you. And I am also generating a secure template to that girl. But both the templates should not be same. Correct or not? So that will lead to again mismatch. Again leads to mismatch. So the technique whatever we are using should generate individual unique templates, right? That is unlinkability. So prevent cross matching attack. Cross matching means let's say she is malicious, but she will be accepted as authorized like this girl because their templates are matching, their feature set is matching, right? So that should not be there, right? So these are the characteristics the method should follow. You can see this is the system architecture of a biometric system. See here, the first step is for any system. First, in Aadhaar or whatever it may be, in any your attendance application also, first we need to register the users. Register the users means enrolling the users. Enrolling, your fingerprints or face should be enrolled into the database. So the first step is enrollment. Then from that image, whatever captured, features will be extracted. Those features will be transformed. What transformation we need to apply? One-way transformation. Reverse should not be possible. Okay? Then transformed, and those templates, they are called protected templates, will be stored in the database or server now. So at the time of authentication, now you need to get your attendance. What you will do? You will present your biometric to the sensor. Correct? You will present your biometric to the sensor, and what it will do? It will extract the features. Then then the reverse, the template will be generated, whatever the algorithm we use, and that is matched with the stored template, enrolled your template, correct? Then if there is a match, your attendance will be marked as present. If there is no match, you are not a authorized user, right? So like that the system will work. Now the different, this is a template, and these are the different attacks. Now, template protection measures. These are the different ways of protecting biometric templates. You can see feature transformation, they are called salting or cancelable biometrics. The next one is biometric crypto systems. So in feature transformation, we will apply one-way transformation, and coming to biometric crypto systems, we will use some cryptographic methods like DES, AES, RSA. Some cryptographic methods will be there. Public key cryptography, private key cryptography. I think in second semester or third year you will have security subject, network security or cryptography. Then you'll get those things. Then other method is homomorphic encryption. Then visual cryptography, hybrid methods and other methods. Visual cryptography? Have you heard about that? Visual cryptography. See, simple. If I store my raw biometric in a server, that is a problem. But if I store I will divide my image, suppose my face image, into shares, not parts wise. In the morning we discussed it, right? Suppose a grayscale image will have pixels in the intensity range from 0 to 255. Let's say I will take small example. Let a 3x3 image, the pixel intensity is 100 here. Pixel intensity is 100, let this is 90, this is 215, this is 55, 42, XYZ. Now what I will do, if this is my original image, image consists of pixels. What is meant by a pixel? Picture element. Picture and means image element. Okay, pixel element. So image consists of pixels, right? So this abbreviation here is a picture element. So these three this is the EL element. Pixel element in short form, that is called pixel. Okay, so image consists of pixels with intensity ranges from 0 to 255 for grayscale image, right? Now what I will do, see, this is my image, let us use face. Now this image is divided into shares, like suppose this is 3x3 again. Here suppose two shares, 50 here, intensity 50, here intensity 50. Now this is 90, this will be 45, this will be 45. This is 215, so 50-50, not possible, but 107, 102 shares. But if I want to divide into 3 shares, let's say this is 33, 33, 33 or 34. This is 30, 30, 30, 3 shares. So this is different image now because the intensities are different. Correct? This is my original image. From this original image, what I am doing? Converting into shares. Shares with different pixel intensities. So different pixel intensities means this will become different image. This will become different image. If I club these two, I will get the original image. Correct or not? Now, instead of storing the original image, I will create the shares, n shares. Here I created 2 shares, but I can create n shares. These n shares will be stored in different servers, different databases. Are you getting or not? While transmitting also, instead of sending all at the same time and at the same link, will follow different links. So the receiver will receive all these n shares via different links. So if the attacker attacks, what will happen? He may get 1 or 2 shares. But my image consists of how many shares? n shares. He may not get all n shares. Even one share missed also, he will not get the original image. My image is safe. Correct or not? So this is called visual cryptography. There are a lot of variants of this. So I can create n shares. N shares will be stored in n databases, n servers. And while communication, while transmission also, these n shares will follow different paths, and all will be received by the receiver to have it. And there are one more variation is there, k out of n. The algorithm will be like this. Even though the image is divided into n shares, at the receiver end, if he is able to get k shares, he may get the original image with 99.9999, like original, but some loss will be there. Okay, but even that is called k out of n technique in visual cryptography, right? Now, anyway, these are all different techniques. Hybrid methods are now is there, like hybrid methods based on AI, deep learning, as well as simple image processing methods. All these are in combined way also people are using for generating or securing the templates. Okay, so here, as of now, we discussed two concepts. One is template security. One is template security, right? And the other is, the part of this is cancelable biometrics. Cancelable, what is cancelable biometrics? If your template is compromised, that should be cancelled and a new one should be generated. Like your password and ID card, right? So that is called cancelable biometrics. So these are the two different, interrelated: biometric template security, cancelable biometric, and one more what we discussed, forgery detection, right? So three different topics, but I am going to cover these two: biometric template protection and cancelable biometrics. Any questions? So the other methods involve steganography and watermarking. What is steganography? This is again another area where you can work on. What is steganography? Health applications, military applications we can use. I'll tell you one example. Suppose in military applications, a commander issued some message. Okay, a commander issued like today 2 p.m. we will attack Pakistan. Let's say that is a message you want to communicate with his peers. His peers are his subordinates. If someone capture that message, what will happen? That information will be leaked to Pakistan. They will alert. Then no meaning of war. Before to that only they will start attack and things will change, right? So those type of communication should be in a secure manner. Suppose let's say if I send that message instead of raw text, like we'll attack at 2 p.m. instead of raw text, I'll convert that text into encoded form. What is meant by encoded form? See, some fuzzy, like A will be transformed into some X, B will be transformed into N, like that. Some encoding mechanism we will use, secret communication, right? Secret communication we will use, and we will send it to the parties. But if a malicious person captures that encoded message, so that encoded message generally will not have any meaningful text. Encoded means no meaning, right? It will be some jigsaw, like that is not at all readable, right? Then he can think that this is some encoded message. So this is an encrypted message. He will try to decrypt it using his knowledge, because I told you, malicious persons always comes with new ideas. If he will decrypt, again what will happen? He'll get the plain text. We'll attack at 2 p.m. Got the message, right? So that is possible, because if we send it in encrypted form, he'll think that there is some important information is there, right? So he'll try to decrypt. But the steganography is a technique where we'll embed the secret text into a cover, right? Like
text will be embedded into that image. Now the image will be transmitted. Now to the malicious person, what is visible? Image. Inside there is text. Now that is secured, right? So he will think that simple image is transmitting. What is this? Okay. But if that is encrypted message, he will think that something is there, I need to decrypt. Right? So that is advantage with steganography. So steganography is the art of hiding secret into a color image. So to the outside world, it will be looks like a image, like an image. But the secret will be there inside that one. Now the receiver will use the same reversible process and he will extract that secret. And now the attack will start at 2 p.m. 2 p.m. over now 2 p.m. Now it will start. Right? So that is the advantage with steganography, right? And other method is watermarking. You know watermark? Read that. Watermark. This watermark is like QR code. Like sorry. This will be used for authenticating a particular copyright. This is little bit different purpose, but only thing is we can verify whether that secret or that particular not only secret, that particular content, multimedia may be image, voice, text, video, whatever it may be, whether it has been altered or not, forged or not, whether that is genuine or not. So this is one different way. So image steganography as well as digital watermarking we can use, but for what purpose we can use? For biometrics. We can verify whether that is a fake biometric or genuine biometric, right? So that is the purpose of digital watermarking. Now, how you will do the steganography? I told you, right? Embedding a text into secret into image. How we can do? This is a common technique in steganography. This is called LSB technique. What is meant by LSB? Least significant bit. Why we call it as least significant? Why we call it as least significant? Least bothered with, least contributed with. Like we'll think in our home also. Okay, for our elders or youngers, our parents will give more priority. Then we'll think that we are least, priority in our home. Like that, this LSB bit is also least bothered. Why least bothered? Low value. No value. Not no value. Low value. Let's say I take one example. What is the binary representation of 15? What is the binary representation of 15? Binary representation of 15. All ones. Right? Now, what is the LSB here? This is LSB. What is this? MSB. Why it is MSB? Most significant. Highest contributed. So what is the equivalent of this? 15. Now, let's say this is what? Least significant. Least bothered. Simply I will change this to 0. Now what is the value of that? What is the value of that? 110. 14. So as I told in the morning, 0 is black, 1 is white, 255 is white. Now what is 254? White only, but small variation, shade change, small, it will not be visible also, right? But if that is, so that's why between 14 and 15, you cannot see the difference. Right? So that bit will use embedding the secret. Embedding the secret. Now let's say this is my image I told you, right? This is my image I told you, right? 100, 90, 15, 25, 40 bits. Now I use this pixel's LSB bit. This pixel's LSB bit. Are you getting or not? LSB bit to embed my secret bit. Secret bit, one bit. So my secret may have many bits. In each pixel, I will embed one here, one. Suppose my image size is, let's say, 200 by 200. 200 by 200. So totally, how many pixels are there? 40,000. 40,000. So 40,000 bits I can embed into the 40,000 secret bits. I can embed into the 200 by 200 bits. Correct or not? Now, see, if I embed, let's say 100, the representation of 100, what is the binary equivalent of 100? What is the binary equivalent of 100? What is the binary equivalent of 100? 64, 32, 96 plus 32, 16, 0, 8, 0, 4, 1, 0, 0. 0, 0. Now what is it? This is the binary equivalent of 100. Now let's say this is a target bit. That is a target bit. I want to embed bit 1 there. See, my secret is having the bits, let's say 1, 1, 0, 1. Now I want to embed this one into 100. I want to embed, this is my secret. I want to embed this 1 into 100. So what is the position? 0. Correct? Now what I will do? Instead of 0, I will make it as 1. What is the pixel intensity now? 100, 101. There is no huge difference. Right? Now at the receiver end, we will follow the same technique. Follow the same technique. LSB contains my secret. So from that 101, we'll take the LSB bit, that is 1 as the secret. So 1 is the secret. Now here also, in 90 also we will embed 1. 15 also we will embed 0. Like that. But easy technique, na? Everyone knows this. If I extract LSB, then the secret will be there. Correct? So this is a basic technique for understanding and explain. But there are many variants of data embedding, secret embedding process. Okay. Even people are using deep learning for this also. Okay, image processing was done. We have few PPTs also I will share with you at the end. This concept I will show you. Right? So this is one method, to protect the secrets. See, this is a image without hidden information. That is a image with hidden information. Any changes? Scenery. Yes, I will share with my friend. Good morning. And that image I will share. Let's say, good morning. Anything is there? Here, any difference? No difference. But the human eye cannot distinguish anything. Right? So, like this, we can use this method for securing the secret information. Right? Now, visual cryptography, I already told you, right? So, this is the functional input. These are the shades. Now, shades we observe. This image is having ridges and valleys. But now this one, a blur image. Correct? Now, this shade will be stored in this server. This shade will be stored in this server. Right? Now, at the receiver end, to get the matching, right? So, share 1 and share 2 will combine to get the test image matching also. At the receiver end. So, during transmission, because the attacker malicious party, you need to get all the shades to get the original image. But it is not possible because they are all shared using different links and they are all stored in different servers. This is other way of securing our templates. Now this is one work we did, finger wheel template protection. Just see this flowchart. What we did. You can also easily do this. See, finger wheel image, finger wheels, they are under the skin, under my skin. More secure. Forgery is not possible. Forgery is not possible. They are under the skin, right? So then how to capture those images? Because skin image, you can have a sensor, you put like that, it will take that, right? It will capture them using some capacitance or magnetic force. Okay. But what about finger wings? They are under the skin. So we need to use a technique called infrared. Infrared cameras, IR. So infrared cameras will work on the principle of temperature, body temperature or some temperature. So see, for a live body there is some temperature. For a dead body, no temperature. So from the dead body or a forged finger, it is not easy to capture the finger wings. Because someone may cut this finger and they take this one into the registration office for registering their lines. But is it possible now? If we use finger wing, not possible, correct? Because cut finger means that is dead. No temperature will be there. So infrared camera will not capture the image under the skin. Somewhat secure, right? Anyway, so the first method, that is the image captured, then image encoding. Image encoding. What is image there? Set of pixel intensities, correct? Set of pixel intensities. Now, the second step, we convert, that is a two-dimensional image, right? Two-dimensional image. Image is two-dimensional generally, correct or not? X coordinate is there, Y coordinate is there. X and Y coordinate, that is like a array. Array is two-dimensional. Then the first step is we need to convert it into 1D. 1D means all the rows will be concatenated. All the rows will be concatenated. Now the one dimension will become 101, 90, 15, 55, 42, X, Y, Z, like that we convert it into 1D vector. Now each of these element is encrypted using simple cryptographic technique like RSA, DS or elliptic curve cryptography we use here. Elliptic curve cryptography is a lightweight cryptographic method. Then now what is meant by encryption? See, we are converting a value, some simple plain value into some coded form. Coded form, correct? But you know these image intensities are in the range of 0 to 255. But the encoded value, even if you encode 10 with the RSA algorithm, the result, the encoded value may be 10,000 or 1 lakh or 5,000, right? But for an image, what is the meaning of pixel intensity of 10,000? No meaning, right? So the next step is, first we need to convert it to image 1D vector, then encrypt using ECC or RSA or some method. Then this is the encrypted 1D vector. Encrypted value. Now the encrypted value of this one is, let's say assume 10,000. This value is 5,000. This value is 999. This value is 400. Right? Now convert these encoded values into images. Is it possible now? Not possible, because pixel intensity should be 0 to 255. Now there are 10,000, 5,000. How you will convert it to image? Not possible, right? So that's why again those values we need to normalize. Normalize between 0 to 255. Normalize between 0 to 255. Suppose if I conduct your exam for 50 marks and at the end exam I need to scale them to 100. How I will do? Suppose let's say your total marks, internal, external for a particular subject, I evaluated for 200 marks or 250 marks. Internal 50-50, measure 50, end exam 150. I conducted, assume total 250. But at the for grading purpose, I need to scale them to 100, 0 to 100. Correct or not? 0 to 100. How I will do? So that process is called normalization. So between 0 to 100, 0 to 100 I will treat now. Here also for the image purpose, image intensity should be 0 to 255. So whatever may be the value, Now it will scale down between 0 to 2. That is called image recoding. Image recoding. Originally we have 0 to 255, but after encryption, the intensity's range becomes more than 255, right? So meaningless. So again we need to convert them into some meaningful form, right? So that is called normalization will apply. Here normalization will apply. Then that normalized image will be enhanced using some filter to get more clarity image. Then that will be fed to a CNN model for training and testing that for CNN model for training all those images and testing purposes. Now this is the original image, finger vein image, right? So finger veins you can see there. These are finger veins, blood vessels, right? This is the encoding scheme. There are many methods. The top one is called LBP, local binary pattern. Don't just note it down. That's it. If you want to read it, you can Google it. You can get the things. LBP, local binary pattern. But for now, it is not required. The second method is direct encoding. So what is direct encoding method? Like 101, 90 to 55. Here also this is 3 by 3. Just converting the rows into a single vector. Okay? Concatenate all the rows. See this here. 132, 131 to 128. 132, 131, 128. Just a single. Then the second row is concatenated here. Third row. So this 2-dimensional becomes now 1-dimensional. Okay? Now these values, this 132 will be encrypted. 131 will be encrypted to get a encrypted values. Right? This is the, you can see, this is the encrypted values. These are the original. 14. We encrypted using ECC. The value becomes 102. 102. 10, 889. 10, 889. Right? So 13, 986. 13, 986. Like that, the encrypted value. But you cannot convert this one into image. Right? So that's why these values again will be scaled down between 0 to 255. See, this is the encrypted image. This is the encrypted image with these normalized values. Sorry, encrypted image with those values, but this is meaningless. So again, it is normalized. So we get 230, 200, 200. That means this is a small portion. That's why those are pixels in this color. So this is the encrypted normalized image. Right? Now this image will be. Now see what I told. The original image is this. The original image is this. Correct? Now the encrypted image is this. We are not storing the original image. Correct? Right. Now this is the original image. Image after RH filter. These are filters for image enhancement, noise removal, all those things. Right? So these are some experiments. Experimental results. So the data set, over the data set, you can see accuracy values. Yes, 0.0661 accuracy and the loss is 4 we show something. But overall, you can see this is a result with RSA. What is RSA? A public key cryptography, asymmetric cryptographic algorithm. This is with RSA and direct encoding, not LBB encoding. So this is a result. This is one method for template, for biometric template protection, right? This is so 92.45. Some these results, anyway, results are not important for us, right? Because for you not important. The concept is important, right? Now, iris. This is a beautiful technique. You can see this is another method for securing iris images. See, what we are doing here, iris generally looks like a, what is this, parabola? What is this? Egg shape, correct? Our eye will be looks like egg shape, oval, correct? Right? So the first step involves segmentation of that image. segmentation of that image, then normalizing that image, segmenting that image and normalizing that image. So this will convert this oval shape iris into a rectangular form, because an image you need to represent always like a rectangular or square, right? So this segmentation will segment the iris pupil and convert it into a rectangular box. Then the beauty of this particular technique is that the image is converted into text. Image is converted into text. Okay, so how we can convert? So for that, here we are using base 64 encoder. You know what is base 64? ASCII, you know? ASCII, American Standard Code for Information Interchange. Right? So like that, base 64 is also a base 64 encoder will be there. So which will convert, means in base 64 encoder, suppose we have to represent, how we will represent A, because you know computer can understand only binary language, correct or not? Computer will understand only binary language, 0 and 1, everything, ABCD, 0 to 9, everything. That image also, I am saying like pixel intensity, 101, 91, like that. But how the computer will store? In the form of binary, zeros and ones, correct? So to represent these ABCDs and 0 to 9 and these special characters, we have a coding scheme called base 64 encoder, so which can represent 64 characters. 64 characters. So how many letters are there? Capital letters 26, small letters 26, total of 52 plus how many numerals? 10, 0 to 9. So total 62, then a dot, a space, a dot, a space. Now what is meant by a word? What is meant by a word and what is meant by a sentence? Word will be mixture of letters and all these things, but separated using space. Now what is a sentence? Sentence will be group of words and space and dot. Correct? So base 64 will have 52 letters, 10 numerals and 1 space and 1 dot. Okay? Now what I will do, this 0 to 255, any pixel is represented with 0 to 255. Now what I will do, from 0 to 255, I will scale down them to 0 to 64. 0 to 64, sorry 63. Now 255 will be represented as 63. 0 is represented as 0. 255 is represented as 63. Now what about 254? Not 62, but so that is called normalizing, scaling down. What I told, your marks, if I conducted exam for 50, but at the end I need to scale down them to 100, 0 to 100. How I will do? So there is a formula called that value minus min by max minus min will give us the normalized value. So see, simple. This x dash for particular x equal to x minus min by max minus min will give us x dash value. Okay, some scaling. This is called standard scalar. Okay, some formula. Now suppose let's say this 101 is there. 101. How we have to scale down? So what is the maximum? What is the maximum? Some scaling you need to do between 0 to 64. Between 0 to 63. Some way of scaling, right? Then now what features I will extract from that text? Now my image is converted into what? Image is converted into what? ABCDs, numbers. Image pixels are converted into ABCDs because my now intensities are between, this will be becomes characters. Now what I will do, the feature set I will extract how many words are there in the image. How many words? How many sentences are there? How many average words per sentence? How many uppercase letters? How many lowercase letters? What is the ratio of uppercase letters to lowercase letters? Right? So like this, we will extract 27 features for each image. For each image. Now these features are fed to a classifier for training. ML model for training. So it will classify, it will train based on the thing, and later will do the testing. So this is an important novel contribution actually. You can see this is a normalized image. The round iris image will be converted into rectangular form. For this also there is a standard open source code is available. That is Darkman's rubber sheet model, right? It is there. Darkman's rubber sheet model. You get the code. This is the invention by IIT Delhi students. Darkman's rubber sheet model, right? Then we will do the base 64 encoder. Base 64 encoder like that, right? This image, what I will do? Image consists of pixel intensities 0 to 255. I will scale down to 0 to 63, right? So this is called base 64 encoder. Now convert the image to text. Now if an image consists of intensity 0, that is space, assuming. Now 1, that is A. 2, B, like that. You can see up to 26, space to Z. Now 27 to 52, small letters. Then 53 to 62, numerals. The last one 63 is the dot. In some assumption, right? Based on now, if the pixel intensity is 0, that is space. Let's say my pixel intensity for this 101, assume we got 40. Assume 40 as per base 64 encoder. Now what is the value I am replacing with that? X, not X. N. Okay. Now this becomes 101 becomes N. 90 becomes X. Assume. 215 becomes 9. Assume. So we converted intensity values which are numerals between 0 to 255 to text. See, now for a human eye, is it possible to get back, that original image? Is it possible? Right? Not possible, right? So that is the way. So we can convert into text. Now from this text, we will apply 17 methods to extract 64 language independent features. These are meaningless. See, that text is meaningless. Will it have any meaningful information? Like, can we read that? And that particular text is not having any meaningful thing. Like, you cannot read it. Random letters are there. Random letters are clubbed into words and sentences. Random letters. So we cannot read it. It's like an encoded value, encoded thing, right? Now from that, we'll convert into 17 methods we'll use and get 26 features. See here, the method 1, the average sentence length in a text. Average sentence length in that particular image. Then percentage of capital letters in relation to the number of lowercase letters. Percentage of capital letters to lowercase letters. The percentage of lowercase letters in relation to the total number of characters in the text. Right? So like that, 26 features are extracted using the number of words of given length in a text. The number of words of given length means the number of words with 3 letters. The number of length, the number of words with 4 letters. The number of words with 5 letters. Correct or not? Suppose ABC, that is 3-letter word. ABCD, 4-letter word. Lakshman, how much? 6. Right? KL, 2. KLU, 3. Correct or not? University. So within a given range. So the number of words between 3 to 5. The number of words between 3 to 5 means combination of 3-letter words, 4-letter words and 5-letter words. So all these constitutes a feature set. So those features now will be given to the machine learning model for classification. Right? So actually the core part only, important part only I use here. So these features extracted will be given to the ML model for training and finally we will do the testing. Right? So that is template protection. Now coming to cancelable biometrics. So we will take 2-minute break, but I want some water please. Right? So this is any questions here? Again, these two works are also published in these two works also published in good journals. Okay. So really looking good na? Something we need to always think. Correct or not? Otherwise, whatever there in the book, we read and write, no use. Right? Then the next method is salting. The next method is salting. Any questions? Okay. This is cancelable part. Means to compromise we have to cancel the old and we have to issue a new one, right? But how we do? The first method is salting. Let's say simple. Okay, don't read that. It will create you a lot of confusion. But I will explain with a simple example. See, that is the original image. Yes, please. That is the original image. But given time is up to 3:30. That's why I will ask you only, just you have to answer. Okay, simple. I will tell you this random sorting concept. Hello, please. Let's say this is the this is the original image. Now I will add some salt to that. Salt means some noise. Some noise. Okay. So for 101, suppose if I add 10, it will become 111. For 90, if I add 10, it will become 100. So like that, to the original image, I will add some noise. So now at the receiving end, we will remove that noise. Or suppose now let's say this is a salting process. For the at the time of testing also, let that 10 is the key here. Let that 10 is the key. Okay. Now same key I will use at the testing time. So I will present my biometric. Now what intensities I will get? 101, 90, these things. Same salt will be applied there. 10, 10, 10, 10, 10. Right? Then 101 becomes 111, 90 becomes 100. My enrolled is also same. Now compare both. Authenticate, right? This is the sorting approach. See that? See and try to translate what you are putting your hands. Just read that. Enrollment is okay. Next. So up to this, it is same like oil, localization, normalization, feature extraction. Now to these features, what we are doing, here we are taking cover image. That image is resized, required as per that, and now that image is encrypted with some key. Now I told you not tell. The image is encrypted with some user specific key, right? Now this is converted into binary code, and we are doing XOR between these features and this binary code. XOR between, what is XOR operation? What is meant by XOR? XOR is a disagreeable gate. Means if both the inputs are different, we will get output 1. Both inputs are different, that means the inputs are 0 1 or 1 0, we will get output as 1. Right? So we are doing some XOR operation between the original image features and encoded cover image. These both this image and this image are performed XOR operation, right? Then that becomes a template. Now how to do the matching process? At the time of verification, at the time of testing, same. Features will be extracted, then same cover image will be taken. User specific key for each user, for you there is a specific key, right? So converting into transferable template, matching, pattern matching. This template and test template, enrolled template and test template will be matched. Then, correct or not? Decision will be taken whether genuine or false. Now how we are achieving cancelability property here. Suppose let's say the stored template is compromised, is hacked. How to generate a new one? Any idea? You have to answer for that. You have to answer for that. See, if your template is compromised, just change your key there, encryption key there. What will then it will give you a different binary code. A different binary code here. See, this is the image same, but if you change your key, what will happen? You will get a different binary code. Now if you XOR your original image, original features with this binary code, you will get a new template. You will get a new template, right? Because you are XORing with different binary code now. Different binary code, right? Why you are getting different binary code? You are applying a different key. You are applying a different key for encryption. See, this is the image. You are encrypting with some key, right? You are getting some image. But if you encrypt with different key, you will get different image, right or not? So that with different image, now you are doing XOR. You will get a different image, right? So the old one is cancelled, and the new one is given to you, right? So this is called cancelable biometric, right? This is one method. Now this is a data set used. Random cross-folding will not get this thing. I will not tell you. Right. This is another method. This is another method. This cross-folding, you can see. This is my left eye. This is my right eye. Really. Right. This is my left eye and right eye. Really. Right? So what I did, I mix these two to have a folded image. This is called random cross folding. So function we need to use? Random function, right? So random matrix is there. From that I will derive a binary matrix. I divide this into a binary matrix, and this is the inverse of this binary. Okay? So the combination of this will give us random matrix. Right? Now to the left eye, what I will do? This B into my left will. P stands for will left. Right will. Right? So multiply this image with this matrix and multiply this image with this matrix. Now combine these two T1 and T2 to get a cross-folded matrix. A cross-folded matrix. Now let us assume my template is compromised again. What I will do? What we need to do again here? Generate a new random matrix specific to you. That maybe your roll number, your date of birth, or some value, whatever, your sister's date of birth, your brother's date of birth, some random number. Right? That is specific to you. That is like your key. That is like your key. You can change anytime that key, right? So you can have that many templates. So this is another method. So this technique, segmentation, these things, this is difficult. Right. Okay, last concept. Just diagram only I will explain. Easy, very easy, dead easy. Okay, fine. Just see the diagram. See the diagram. Looking very complicated, but very easy. I'll tell you. Up to this, see, you see only the modules. This is the feature extraction stage. You can observe here. Feature extraction. Right? So, here we are using a deep learning model to extract the features from the biometric. Feature maps, CNN will extract the feature maps. Okay? So, here we are using a CNN and RNN. That is GRU. CNN and RNN. GRU, gated recurrent unit, okay, to extract the features. So if you want details about this, go and search the Google, okay. So the CNN and GRU will be presented with our iris, right. Now it will give us a feature map of 256, 1 cross 256 elements. Now this will be applied to a random projection model. Random projection. This 256 now will be random, using a random projection method. We are projecting that, and this left iris and this is the right iris, same process. For left iris, we are extracting the features of 256. For right iris, using same model, we are extracting the feature map, and using the random projection method, we are projecting that, and we are fusing them to have a feature vector, and this will be given to the classifier for training and classification purpose. So this is the enrollment phase, this is the testing phase. Now what is this random projection method? How cancelability property we are getting here? See here, this is a user key. Now using this user key, we are projecting this one. So this user key is a 4x4 vector, 4x4 matrix, 4x4 matrix, user key, right? Now this will be converted into 1/16. 4x4 means 2-dimensional. 4x4 means 2-dimensional. I will convert that one into 1 cross 16 means 1-dimensional. Now, from the feature extraction, here I am getting 1 cross 256. 1 cross 256. Right? Now, this will be multiplied with this 1 cross 16 user specific key. User specific key is 4x4. Right? So, I will convert it into 1 cross 16, and this 1 cross 256 will be multiplied with 16 cross 1. Is it possible? Because the columns of first matrix should be equal to the rows or columns. What? Columns of
should be equal to rows of second. So that's why this is 256 cross 1, 256 cross 1, and now this is 1 cross 16. Done? Right? Now to have, now if we multiply this, we will get a fusion of 16 cross 256, because these 256 elements are multiplying with 16 elements. Right? Each row of this is multiplying with 16 elements. Right? So we will have a 16 by 256. Now this is a 16 by 256. This feature we will use for classification purpose. Simple. Now let this is compromised. Let this is compromised. Let that template is compromised. What we need to do? Generate a new user key. New user specific key for you. So that will generate you a new key, a new matrix, a new feature set, new template. Problem solved. Right? So this is the way of doing template security and generating cancelable templates for. But here we haven't addressed distinguishing between real and fake. Real and fake. Lot of other works also there, like what I told, data hiding. 10 more minutes is there. Any questions? No. For 10 more minutes. Any questions, please? Any questions, please? So this is a serial network, parallel network, cross folding. Right? Any questions, please? See that? Military applications. Military applications we can use. And medical. See, a person is having some disease. Okay, nowadays everything is telemedicine, correct? So the reports will be sent over the internet. And if that report contains, that MRI or Xerox contains the patient information, what will happen? If your X-ray contains your information, what will happen? Your disease will be known to malicious person. Then what will you do? Next day you come to the class. So he is having X, Y, Z. Even X is there. You'll add Y also. You'll add Z also. And you'll publish it, right? So what we need to do? We need to protect. This is my second time. Recently, BB8, same thing was happened. Students actually, I am not because student nature. My students will listen my this thing because right, but you will not listen. This is not the way. Hello, hey, Ula Choka. See, let's stand up. So, how we can use the secret data sharing for medical applications? So we need to hide the patient data. Along with the X-ray or MRI, whatever it may be. If the patient data is there, metadata like his name, his village, everything, then his privacy what happened to his privacy? No privacy, right? So that information should be
show you. There are many methods. Again, cryptography we can use. Cryptography we can use. But what cryptography we chose? This is the original image encrypted. By seeing this, someone may guess, Ray, this in encrypted format means some secret is there. I need to decrypt it. Then he will try his methods. Finally, he is able to decrypt. Right? Then privacy. Where is privacy? Where is secrecy? Where is confidential? Right? So that's why cryptographic methods will not use for these purposes. Right? Then this is the process, reversible data hiding. Right? So we need to hide the data into a cover image, a scenery, at the reverse, at the receiver end. We need to retrieve back that. This is called reversible data hiding. So there are many applications like electronic health records, military applications. So this is the steganography process. This is the cover media. Into which we are embedding the secret. The secret is embedded into cover media, right? Using some key. This is optional again. Okay, this is required sometime. This is not required. So this encoded image is now called stego. But the stego image looks similar to cover image. The stego is the combination of cover as well as secret. But the secret will be embedded into that. Okay, in invisible mode. Okay, this will be visible to the outside world, right? The extracting process, using the same process, we will extract the secret message from this stego. This is called steganography. And visual cryptography we discussed. But now, what are the evaluation metrics for this? See, what I told is cover image and stego image should be similar. So, how much similar they are? Right? So, we have a performance measure called SSIM, Structural Similarity Index measure. So, that we will use to measure the similarity between cover image and stego image. And one more important thing, at the receiver end, we need to extract the same secret. But what is the original secret and what is the extracted secret? Both should be same. But sometimes due to noise, environmental noise, or some factors, some noise may be introduced. That 1 may become 0, 0 may become 1. If 1 becomes 0, what will happen? That 4 ones becomes, the last one becomes 0, 15 becomes 14. Right? So, how much similarity is there between secret message and extracted message? What is the similarity between stego image as well as cover image? So, these are the performance measure we use is SSIM, and one more is mean square error, MSE. Okay, this is MSE PSNR, and one more, peak signal to noise ratio. That is how much noise introduced and what is the original image. SSIM. So this is the related work. So people use LSB technique. You can see this is different LSB technique here. Because what I told, if we use simple LSB, what will happen? Everyone can guess. The LSB always consists of the secret text. So it is easy to extract the secret. So instead of that, there are a lot of variants. So here, the image you can see is divided into 3 regions. Simple concept, you will get the thing. So now you can think of how we can do in a different way. Okay, simple concept. Listen for 2 minutes, then it will be clear to you. See, the image is divided into 3 regions. So all the pixels above some threshold. We fix 2 thresholds here. going into 3 regions. Okay, let's say my T1 is 70. T1 is 70. So all the pixels from 0 to 69 are in lower level. The next, the threshold 2 is 180, assume. Now the pixels from 70 to 180 are in the medium level. Now high level 181 to 255. All the pixels in my image are at higher level. The pixel intensities are between 180 to 255. Assume. Okay. So the same technique. See here we are taking 86 and 171. So the pixels less than 86 are lower level, 86 to 171 middle level, 170 to 255 are higher level. Now LSB technique only, but some variation. Okay. So if the gray level image is 0 to 85, then change the third bit of the third LSB bit. Are you getting or not? Third LSB bit, not first LSB, second LSB. Third LSB bit. What is the weight of third LSB? What is the weight of third LSB? 4, correct or not? What is the weight of second LSB? 2. What is the weight of first LSB? 1. Okay. So if the intensity, what is that? Pixel intensity is less than 86, 0 to 85, then change the third LSB with the adjustment of first and second. So total what I told, if we change the LSB bit, what will happen? The value will change. If we change 15, that means 1111 to 1110, 15 becomes 14, right? Now if I change the third LSB, what will happen there? 4 ones are there, right? 4 ones. If I change this, it will become 15 to 11. 15 to 11. But there is a change, there is a gap, correct? Now we need to adjust first and second LSB by changing. In third LSB place, we are putting the secret. In third LSB place, we are putting the secret bit. But we are adjusting the first and second LSB so that the total weight should be closer to 15. Closer to 15 in this case. Okay, right? And if the gray level range is 86 to 170, then the second bit with the adjustment of first bit. Second bit will be the target by adjusting the first bit, so that the total value should be closer to the original value, right? And if the gray level range is 170 to 255, change the first element. Change the first element. Only last bit will be changed. So last bit will be changed means it will be closer to the original value, right? The last bit is changed. What will happen? It will become 14 instead of 15. No adjustment is required. Only one bit change. Only one bit change, right? So like that, see in the first case, suppose the randomly selected pixel value is 83. 83 means it is less than 86. Means we need to, the target bit is what? Third pixel and adjustment of first and second. So see here, the bit value of third LSB is extracted, which is 0 now. Extraction procedure, but embedding process. Embedding process. I have taken one example. Okay, extraction procedure is here. Okay. Now third LSB is extracted to get the original secret, and if the value is between 86 to 170 something, as this is 153, we need to extract the second bit, and 236 the last bit. So like that, we will come at the receiver end, we are able to get the secret, right? But to the outside world, as we adjusted the remaining bits to the outside world, it will look like only cover image. The stego image looks like only cover image. So medical applications will use. So DL based methods also there. So here used encoder decoder architecture. This is another method. See, using visual cryptography. Cover image, Lena, not Tina. This is Lena image. So in image processing, people will use any research paper. Mostly people will use this image. So now this MRI is this girl's. Now her image is embedded into stego. This MRI to the outside world. So now you can see if we embed this, but this stego image decoder architecture here. This is a deep learning model. This is embedding process. So this particular layers will extract the features from these images, and this is the embedding network. This is encoder part. This is called encoder decoder architecture, auto encoder. Now this is Lego image. You can see this Lego image. Looks like cover image. Looks like cover image. Now this will be sent to the doctor or patient. Okay. Now if a malicious person captures that, what he can see? Cover image. Now what the doctor what will do? He follow the reverse procedure to extract the model. Okay. So this work we did. This is our model here, embedding and extraction, and these are the data sets we use. These are some results. PSNR, host PSNR, and payload PSNR. What is host PSNR? What is meant by host PSNR? Cover image to stego image. What is payload PSNR? Secret to extracted secret. Okay, how much similar they are, right? And this is SSIM, and these are the results and different data sets. Any questions, please? Any questions? Any questions? So how you can improvise them? Even recently, four in Warangal SR University, four of my students, that means interns, they came, they worked with me for 2 months, not 2 months exactly, 1 month 15 days, and everyone got one paper. Close. Okay, so easy. The easiest way is search papers with code, search GitHub, search Kaggle. You get the data sets and you get the code, open source code. You can download it and you can experiment it. If you have any doubt, ask ChatGPT. Even if you give the concept also, I need to do this. Suggest a model, but you need to customize. See, the next level is not learning these technologies. How to use AI means that ChatGPT. If you are able to use it efficiently, task is done. Nowadays, I am not writing links, masking. So I need to write a mail to that editor. Please suggest a. So he is giving very good. Okay, that its IQ level is 110.
Hello.
Be silent. Please maintain silence for 5 minutes. 5 minutes. 5 minutes.
Session will be wind up.
Wind up. Attendance everything.
Thank you, sir, for this informative session. As a cybersecurity student, this was a very helpful session for me, especially the second one. So I hope everybody learned a lot of new information, and I hope it was very interesting. I'd like to invite our faculty members to facilitate our speaker today.